So, let's get right into one of the most important ideas in all of artificial intelligence. It's the difference between training data and testing data. Now, this might sound like a technical detail, but trust me, it's the core secret to making sure an AI is actually smart and not just really good at cheating on a test.
You know that feeling, right? You've got a huge exam, you pull an all-nighter, you just cram every single fact into your brain, and yeah, you might even ace the test, but a week later, it's all gone. Well, it turns out AI models can fall into that exact same trap. The good news is, in the world of AI, there's a really clever way to stop that from happening.
You see, this whole human experience, the difference between just memorizing something for a short time versus actually learning it, well, it has a perfect parallel in machine learning. So the big question is, how do we force an AI to truly learn and not just cram for the exam? The goal is to get it to generalize.
Think about it. For an AI to be useful in the real world, it can't just memorize the specific pictures of cats it's already seen. It has to actually understand the idea of catness so it can spot a cat it's never seen before. It needs to apply its knowledge to totally new situations, just like a student has to go from doing the homework to acing the final exam.
Okay, so to make sure our AI is a real learner and not just a crammer, we basically split its entire education into two key parts. There's the textbook it gets to study from, and then there's the final exam it has to pass.
First up, you've got the training data. This is the AI's textbook, its study guide, its lecture notes. It's everything it's allowed to look at to learn. For an AI learning to spot cats, this could be millions of pictures of cats, all labeled. The model just pores over this massive collection, looking for patterns, and slowly building its own internal logic for what makes a cat, well, a cat.
And then you have the testing data. This is the final exam. And the most important rule here is that the model has never, ever seen this data before. We keep it locked away, completely separate, during the whole learning phase. This is how we get a truly honest, unbiased grade on how well the model can apply what it's learned to something new.
So how do we split it up? Well, a really common way to do it in the industry is this 80-20 split. The model gets a whopping 80% of all the data to study and learn from. We then hold back that last 20% for the final make-or-break test. So as you can see, it spends way more time learning than it ever does being graded.
The big takeaway here is that these two datasets have completely different jobs. The training data is there to teach. The testing data is there to grade. One is an open book for the model to learn from, and the other is kept totally secret until the very end. They work together, but they can absolutely never mix. And this super strict separation, this wall between the textbook and the exam, it's probably the single most important rule in this whole process. So, what happens if we break that rule?
It's a simple question, right? But the answer is the entire reason we do this. What actually happens if the lines get blurry? What if the AI gets a little sneak peek at the questions that are going to be on the final exam?
Well, what happens is a huge problem called overfitting. And really, overfitting is the villain of our story today. This is when the model doesn't just learn the important patterns, it learns everything, including all the random noise, the weird quirks, and the flaws in the training data. It's not learning the subject anymore, it's just memorizing the answer key.
The result of all that? You get an AI that looks like an absolute genius in the lab. It'll get a 100% score on the data it was trained on. But the second you put it out into the real world and give it a problem it's never seen before, it completely falls apart. It's useless, or in some cases, it can even be dangerous.
All right, so now that we know why separating our data is so critical, let's just quickly walk through how the whole process actually works. It's a pretty simple and logical flow.
This pretty much sums it up perfectly. Step 1 is feed. You give the model its textbook, that big training data set, and you just let it go to town. Then in step 2, the model starts to define its own understanding. It sifts through all that data, finds the patterns, and builds its own logic. And finally, step 3, test. We bring out that unseen final exam to get a true, honest score of how it'll perform in the wild.
So when all is said and done, why does this whole distinction between a textbook and a test actually matter to you?
It matters because this whole process is the absolute bedrock of building AI we can actually trust. Doing it this way stops models from just being good memorizers and forces them to actually work in the messy, unpredictable real world. It gives us an honest grade on how accurate and reliable a system is. And that is mission critical for the AI tools we depend on every single day.
You know, the source material for this explainer really says it all right here. The testing data is the final real check. It is that moment of truth. It's what tells us if the AI has actually learned something useful or if it just got really good at faking it.
And this brings us to one last, really critical thought. This whole system is designed to give us an honest grade on the AI's performance, but that grade is only as good as the test itself. If our testing data, our final exam, doesn't really represent the real world accurately, with all its complexities and biases, then an AI can pass with flying colors and still be deeply flawed. So the question we're left with is, how do we make sure the tests we're giving our AI are the right ones?